everybody. Welcome back to Chem 121. We are almost at midterm, so we have just a little bit left to do today. We have to name covalent compounds. And then the rest of the day is a review session. So hopefully people have questions for that. And then some other stuff is due this week before your exam. So, last call for quiz number 4 tonight. Get it in by the deadline, or else it will close and is gone forever. And then lab worksheet number 2 is due tonight as well. The soft deadline, that's a soft deadline. The hard deadline is tomorrow. Here is a cat that really wants to say hi. Say hi, Maya. There you go. Okay. Maya meows on command. I should really start giving her like treats or something for that. I'm in the wrong window. I need to be in this window. There we go. Maya, you gotta move. I gotta move my chair up. Maya, move out of the way. Sorry, cat. Technical cat difficulties here. There we go. I don't want to roll over your paw. Yeah, Maya always is just like, she's a talker. I mean, both of my cats talk, but the other one is, I put the mic next to him and he's like, I don't know what to do with this. Maya loves talking, though. Alright, so what we're going to do is, for this last little bit of lecture, we're going to name covalent compounds. And naming covalent compounds, these rules are dumb. Where is... Wait, hold on, just a second. Sorry, hold on. Did I load the wrong slides? Sorry, I was expecting a different slide there. Hold on. Weird. Okay, you know what I'm gonna do? I'm just gonna replace the slides here. So these slides will be a little different than what you have in there. Yeah, I have Garbo slides here. I'm gonna leave what's there. No, we don't care about this, so I'm just gonna delete it. Okay, never mind. Sorry. Here I am sitting here editing my slides here. So this is the slide I was expecting. So on the first thing with naming ionic compounds, I gave you something that looked like this, and I was surprised I didn't see it here. So molecular compounds follow a different sort of scheme, but it's only subtly different. And so you'll notice that we still have named the first thing, named the second thing with "ide," but instead we have this pound sign, this hashtag. And so what this means is we're going to add a numeric prefix. And that's going to indicate how many that we have. Now, we have talked about electronegativity. So the element that is more electronegative goes second. The element that's less electronegative goes first. So when it says name the first element and then name the second element, you're just going to sort them by electronegativity. Generally speaking, I have already done that for you, so you're probably not going to run into a situation where you have to decide which of these is the right formula. Does this come first or this come first? If you're ever concerned that, like, oh, maybe it's written in the wrong order, or you just aren't sure if you're entering it in the correct way, the more electronegative element goes last. Put the positive thing first, put the negative thing last. In the boxes that have the pound symbol, you're going to use a numeric prefix. I'm going to show you these on the next slide. But you only use these for covalent compounds, so never use these numeric prefixes for ionic compounds. So molecular compounds get numeric prefixes. Ionic compounds get Roman numerals for metals. Okay, so never use Roman numerals in molecular compounds. All right. So here are the numeric prefixes right here. If you have one of something, then we put mono in front of it. If you have two of something, you put di in front of it, and so on and so forth. So this goes all the way up to 10. That's as high as we're going to go in this class. Now, there are some exceptions. So you can see that this is one sometimes omitted. And so this is one of the first exceptions. So the first exception is if there's only one of the first element, omit mono. So, for example, on the bottom there, you'll see CO2. CO2, we would not call it monocarbon dioxide. We just say carbon dioxide. The mono in the front of the first element is just, it's assumed. If we don't write the word, if we don't write a prefix, it's assumed to be one. If I had something like this instead, so like if I had C2O2, this would be dicarbon dioxide. And so if there's one of the first element, that's the only time you omit a prefix. So you omit mono in that case. Now, in some cases, you're going to get a weird vowel combination. And what we do is we drop the last letter on the prefix to make it sound better. So if you get an A and an O together, or an O and an O together, drop the first letter to make it sound better. So for instance, right here, I have P2O5, which would be diphosphorus, because there's two phosphoruses. And then for 5, the prefix is penta. Where is it? There it is. But pentaoxide sounds like too many syllables. So we make it pentoxide. And you'll notice that the A here was dropped. Same with carbon monoxide. Instead of having monooxide or monoxide or something like that, we get rid of the first of the two vowels. For whatever reason, when we have an I and an O, that's okay. I'm not really sure why. Somebody just went through these and was like, double O, no, that's not okay. Yeah, that makes sense. AO, not okay. Oh, well, all right. That sort of thing. But that's more or less it. That's how you name molecular compounds. You're going to find the name of the first element, find the name of the second element with "ide." It's all the same "ides" that we covered in Unit 4. And then you're going to apply these numeric prefixes. No Roman numerals ever in molecular compounds. And the reason for that is molecular compounds do not contain charges. Roman numerals are only for the charges on metals that are variable charged. All right, so I got some examples here. So what would I call this? You can type your answer right in the chat. Dinitrogen pentoxide is correct. Very good. I'm in my email. I should probably get back to here. Here we go. How about this one? I mean, you already know what that one's called, right? What about this one, though? Can't call it water. That's not its scientific name. That's not its IUPAC name. Yep, dinitrogen pentoxide is correct. Very good. But what about H2O? I know the temptation to type in water is there, but that's a common name. What's the actual chemical name of this? Yeah, there you go. Dihydrogen monoxide. Now, dihydrogen monoxide is a rather controversial name because it sounds kind of chemically. I wonder if people might abuse that. I don't like where this is going. So this is a joke that I tell everybody every year. Whenever I teach 140, 121, 161, we talk about the petition to ban dihydrogen monoxide. This is a real thing. This was a real thing that was done as a joke to highlight chemical awareness. And what somebody did is they went through and found a bunch of reasons why this chemical, dihydrogen monoxide, abbreviated DHMO, to sound scary, was bad. And here are the reasons that they came up with. So another name for it is hydroxyl acid. It is the major component of acid rain. That's kind of scary, right? Most of rain is dihydrogen monoxide. Bad. Especially acid rain. It contributes to the greenhouse effect. Yeah, it causes warming. Have you ever noticed that on days that are cloudy, it tends to be a little warmer? It can cause severe burns if you contact it, and if you breathe it, you will die. What else does it do? It causes erosion. It corrodes metals. It causes electrical failures, and your car and automobile brakes are not as responsive. So this stuff is everywhere. It's insidious. Every single person who has died from cancer has this in their body. Like, what the hell? How can we allow this in our society? What is wrong with us? And yet, despite all of this, dihydrogen monoxide is everywhere. It's used in industry as a coolant. It's used as solvent. It's used in nuclear power. We use it to make styrofoam. We use it as a fire retardant. We use it in animal research. It's so cruel. It's used in pesticide. Even if you wash your produce, it's still contaminated by dihydrogen monoxide. It's in junk food. It's everywhere. And yet at the end of the day, what is it? It's fucking water. Right? Like, this is the stupidest thing ever. Who would be fooled by this because you're in a chemistry class, right? Like, it's water. Of course water does all these things. Of course water is the major component of acid rain, because acid rain is rain, and there's water in it. Of course it's fatal if you inhale it. You'll drown. Like, duh, right? Like, but you can manipulate these facts in such an interesting way that people got real upset when they heard about dihydrogen monoxide. So I have two examples. One of these happened in America, and the other one happened in another country. I think it was Australia. You'll immediately be able to tell which one's which. The first scenario was this bill was brought to a Senate or Congress meeting, and then all of the people voted on it, and then had an actual conversation about how, like, yeah, chemical awareness is not very high. It's really important to know what these things are so that you don't get fooled by this. That doesn't sound like something our Congress would ever do, right? So, yeah, naturally, that was the Australia case. Here's the America case. A radio station, I want to say it was in Atlanta, on April Fool's, ran a bit about dihydrogen monoxide and how it was everywhere, and it was in all of the local supplies for drinking water and stuff. And they listed a bunch of these facts, and within an hour, thousands of people had called in a panic, and I think like their show went off the air for the rest of that day. Maybe like it was taken off permanently. I'll have to find the article during the break, but the whole point of studying nomenclature is so that you don't freak out when somebody says a relatively chemically sounding name. Like, this is really important in a time where we're all trying to get vaccinated, because one of the scare tactics that people will say is like, oh my goodness, did you know vaccines contain mercaptothiol or something like that? And then you realize, oh, that's just a bunch of carbons with a sulfur on it. Your proteins have that. In fact, duh, it's proteins. It's a vaccine, right? So that's a bad example because I'm just making up a chemically sounding thing. But a lot of scare tactics from people who don't understand what these chemicals are will use the names as a scare tactic to try and fool you, or at least convince you otherwise. But study the science and then trust the science, and don't be fooled by fake science, or pseudoscience is what I was going for there. All right, I'm going to put these on the board here. What I want you to do is give me the name of these 4 at the top, but you also have to work backwards. I want you to give me the formula when I give you these 3 names, and then I think there's a homework practice there at the bottom. So I'm going to give you about 5 minutes to do this, and this is it. That's all we have to do. So we're going to do the review after that. So type in your answers, and then if you have review questions, you can go ahead and start typing in those too, and we'll get to those later on. So I found the article. It was actually in Florida, but I'm going to read this article to you while you're working, just in case you wanted to get a little bit of a, I don't know, you just want to feel sad for America here. Okay. So the title is Florida DJs May Face Felony for April Fool's Water Joke Worse Than Rubio's. Florida County radio morning show hosts Val St. John and Scott Fish are currently serving indefinite suspensions, and possibly worse, over a successful April Fool's Day prank. They told their listeners that dihydrogen monoxide was coming out of their taps throughout the Fort Myers area. Dihydrogen monoxide is water. The popular DJs are mainly in all this trouble, possibly of a felony level, because their listeners panicked so much about the molecular makeup of their drinking water, however unwittingly, that Lee County utility officials had to issue a county-wide statement calming the fears of the chemistry-challenged Floridians. And this keeps going like that. I'll post the link to the article here. But it's just like, holy shit, you guys. Yeah. Don't be Florida in this case. If any of you are from Florida, I apologize, and I'm also sorry. But not for the reason that you think, probably. All right, I'll give you 2 more minutes to go over the answers, or before we go over the answers. Oh, I didn't actually mute my mic here. Okay. I'm ready to go over these. Let's see here. So for N2O, we have 2 nitrogens, so I'd say dinitrogen. And then 1 oxygen, so that's monoxide. Just to avoid the double O there. For the second one, I have dichlorine. Trioxide. Then I have sulfur. There's only 1 of them, and it's the first element, so I don't need mono. And then hexafluoride. Be real careful with spelling. And then finally, for P4O10, we have tetra phosphorus decoxide. We want to avoid that AO combo. And then down here, making formulas out of these names I think is really easy because di is 2 of these, and it's boron. So we got that, and then trioxide is O3. Carbon, whoop, disulfide, so sulfur with a 2. And then oxygen, difluoride, F2. There you go. So it should be deca. So the prefix is deca. But if you end with if you have something like this, and you have that AO combo, then we get rid of the A. And so it becomes decoxide. So it's deca, but it's deco only if you're on oxygen. All right, that's all I got. So there's the homework practice at the bottom down there. So that's the end of the chapter. So yeah, that should be the happy orc there. So we'll turn up the music here so you get to hear that. That is such an old picture. All right, so that's the end of chapter 5. what that means is that we've covered all of the content that will be on exam number 1 now. And so the rest of the period is just review. So I'm going to click on this box over here. We don't really need the PowerPoint window up, so I'll just clear that out of the way. But I do have this document that I do want to share with students here. That's not the document. Oh, maybe I got rid of it. Let me just go find the email that the student asked me, because it's kind of applicable to like every class that I have here. And they're useful questions, actually. So if I could copy and paste. Copy. All right, so I'm going to use the students' questions again, because they're good questions. Boop. Can't see anything. Hold on. Boop. That's not helpful. All right, so this is from a different class, but a student asked me these questions, and I thought this actually helps a lot of students prepare. So I do have to look some of this information up because it's different depending on what class we're in. So 121 has different stipulations than 140 versus 160 or whatever. So let me go into exam number 1 here. All right, so there are 42 questions. Oops, caps lock. And you get 2 hours to do it. So you have plenty of time to do the exam. And you do get 2 attempts, so make sure that you don't start at like 11:30 p.m. because you'll run out of time and then you can't use your second attempt because it'll close. So yeah, you do get a second attempt. I wouldn't be... I would recommend, like, don't be super nervous about this because people do better on the exams than the quizzes. And they're very similar. So when is the exam? So the exam is open from Friday from midnight to 11:59. It's open that entire day. So you get all day to do the exam. But you have to finish your exam, I want to say, before the deadline. So make sure you give yourself enough time. If you're going to use both attempts and you need all 4 hours, like, that's a lot of time. So just be mindful of that. Can we go through some of the problems that might be on the exam? Yes, that's the point of the review session today, right? So if you have questions that you think are good exam candidates, we can go over those questions today. Will you have to submit any work for the exam? No. Canvas will not allow you to upload anything for the exam. And also, there's really no equitable or fair way that I can assume that you can upload all of that while the exam timer is going. Like, what if you hit a technical difficulty trying to take a snapshot from your phone, sending it to your computer, and then uploading it? Like, that's not cool. I don't want you to have to deal with that. Excuse me. Are grades curved according to class scores? So grades are curved. I'm going to put it in quotes. At the end of the quarter. So I don't curve your exam because, pragmatically speaking, curving actually lowers your scores. Believe it or not. My exams are not written so that the class average is 40%. My class average is written so the average is where it should be, average. So I shouldn't have to curve the score at all. But generally speaking, there are more opportunities for more points. And so students score better than average on exams using data that I have. And if I curved your scores, everybody's score would go down. So avoid the word curve. Curve is not what you think it is. At the end of the quarter, I do raise scores all slightly, somewhat based on issues that we ran into. So, like maybe problems that didn't work on the exam or technical problems or whatever. Sarah, I'll answer your question at the end of all of these here. So, but remind me, I don't want to forget about it. Do you have some tips for the exam? So, my advice for the exam is to review the worksheets and do practice problems from the textbook. And also know how to do the quiz problems from the chapter quizzes. So, I think that that's super, super relevant because, one, the quiz problems are very similar in nature to your exam problems because they're all sort of in the pools together. Like, the pools have a lot of overlap. So, the exam problems that I give you come from different pools. Some of those problems are on your quizzes. So, there is a chance you might just see quiz problems again. However, the odds of that are very low. I quoted it as like 1 in 20 earlier this morning, and I'll stick to that. Because the odds of you getting a problem exactly the same as one you've seen before, there's just so many possibilities. And also, will you remember that problem, or is it a number problem where it's just a randomly generated number? So you won't see exactly the same problem, but you will see similar problems. Where did those problems come from? Well, they came from the textbook and the worksheets. So if you know how to do the worksheets and the textbook problems, you should have no problem doing the exam problems. Can we backtrack? So no backtracking is allowed. And the reason for that is because you can use any resource that you want on the exam. And then this isn't a question, so we'll just get rid of that. You can use any resource that you want to. That includes other people on the exam. So 2 hours is a long time. It is feasible that you could all get together and just like make a big phone call and then talk to each other and then guide yourselves through the exam. The problem with doing that is that you'll run out of time anyway, because your exams are in random orders, and you can only do one problem at a time, and you can't go back. So the first problem, you all do the problem, but you all have unique problems, and so you're not helpful to each other. Then you go on to the second problem, and you obviously don't want to wait for other people because the exam is timed. So then you all get desynchronized. And then it's like, oh, did anybody have that question about the covalent bonds with carbon? And maybe some people had that, maybe not. So this isn't really helping you to work together. And that's the reason why I have to set this up, is because what other instructors would call cheating, I don't really have a problem with because I've set it up this way. Because you can talk to other people, that's okay, but at most you're not going to get all the answers from your buddy in a 2-hour exam period when your questions are randomized and one at a time. Like, it's just too difficult and too cumbersome to do. So I'm sort of trying to discourage you from doing these things and instead rely upon your own brain power, because the fastest and most reliable method on the exam to be successful is to know all the content and be able to do it yourself. And if you can do that, then this exam will be easy regardless of what hurdles I've put in your way. So that's why you're not allowed to backtrack. Other questions that students are asking on the on here. So let's see here. So you do get 2 attempts. Both attempts are just 1 day, so it's only open Friday. If Friday is a really bad day for you, email me. I can move your exam to Thursday or Saturday. I have to be within 1 day of that. I can't push it to next week, for example. I can't push it back in time. So it's got to be within 1 day of Friday, but I can move that. And then is the second exam going to be on chapters 6 through 10? Yeah, so exam 2 is 6 through 10. The final is 1 through 10. So we've covered absolutely nothing on exam 2 yet. That's what the second half of the quarter is for. All right, so I'm going to close this guy. Boop. And then we'll answer some of these other questions. So what decides the charge on transition metals? So transition metals have charges. And depending on the nature of the problem that you're looking at, you're either going to solve for it or it's going to be told to you. For example, if I gave you this compound, I mean, if my pen didn't screw up here, and I said, what's the charge on iron? Then what you would have to do is you'd have to say, okay, well, I know that if I split this into things, I'm going to have an iron and then 3 chlorines. And I know that when I draw the Lewis structure for chlorine in an ionic compound, it looks like that. So to get to its octet, I would have to do that to it. So these are all minus. The total negative charge that I have is -3. My iron needs to have something to counteract that because it's electrically neutral. So it must be this. So there you go. So now that you know that, you could then write its name as iron 3. So that's an example of when your charges will be calculated on transition metals. For any transition metal, you're going to have to find out the charge either because you have to do this sort of process, or I just tell you. So if you had to name like chromium 4 oxide, then you just know right away that, oh, okay, well, this is just this. And then I know what oxide is. So now I can get the formula. Those are the two situations I can think of for ionic compounds. Is I give you a formula and you have to figure out the charge. Excuse me. Or I give you the name and then you can translate that into a formula. So Matthew, when you say rounding problems in sig figs, can you be more specific, or even type one in the chat for me to do? Because I don't know specifically what you mean. When is your Chapter 5 quiz? I'm going to post it tonight, so that's going to unlock. However, it's not going to be due until next week. I will set it so that you get to see your answers afterwards. So if you want to take the Chapter 5 quiz now, and then just see the questions, and then have that available to study for the exam, you could totally do that. So conversion problems for word problems. If you have examples like from the textbook, type them in, and I can definitely do those. So for those numbers that you wrote on this, oops, what did I just delete? What am I'm not in the window I think I'm in. There we go. There we go. So for those numbers that you wrote, so if you're counting sig figs for these numbers, so I'm going to do the bottom one here first. So remember that anything that's not 0 is a sig fig. So these are sig figs. And then these zeros right here, if I can cross them out and it changes the value of the number, they must have been placeholders, right? So 12,500 became 125. I needed those zeros so that I had the right magnitude, so these must be placeholders. Why didn't I undo that? Oh, Photoshop, why are you the worst? Sometimes, okay. I had to do that. There we go. So this number as written would have 3 sig figs. For this number up here, obviously these two are sig figs because they're not zeros, but I have this decimal. And so you have to remember the decimal rule. For the decimal rule, any numbers to the right of a sig fig are also sig figs, and any numbers to the left are placeholders. So this number as written here, 0.0250, also has 3 sig figs. We're actually at the break time for the class almost. Like, just we're a little early. So what I want to do is I'm going to put the timer on the screen here for the break, and then I'm going to let you have 10 minutes to type any questions in that you want to ask. So try to be specific. If you can give me a specific question to do, that's more effective than just a topic, because I can talk about the topic, but you probably want to see examples is what I'm thinking. So try and find any examples that you can and just type them in. Like that. So yeah, if you had 0.025, that's just 2 sig figs. But yeah, ask me questions like that, and I'll give you 10 minutes to do that over the break. And then, of course, go fill your water. So we'll start that. We'll get this started. And I'll see you in a bit. we are back. It's a good time for the music to stop there. All right, so I got a bunch of questions in the chat that are... Oh, I'm in the wrong window. I'm like, where'd everything go? That are of the nature of sort of story problems. So we'll go over these. So the first problem I'm looking at is up here. I guess I'll highlight it so that we can... There we go. Oh, now I can't read it if I click on another window. Okay, well, it's that one. You know which one it is now. So it takes a motorcycle carrying 2 passengers about 32.6 minutes to drive from Everett to Seattle. If the motorcycle travels at this speed, what distance did the motorcyclist travel in centimeters? So we have 32.6 minutes. That's the time that they traveled. And they are going 71.3 miles per hour. That's the speed. And we want to know the distance in centimeters. I shouldn't put an equal there, but... All right. So the way that you can do this is if you know how much time you're using. So time can be turned into a distance by using the speed, right? So if I have the number of minutes, I could turn that into hours, which I can then turn into miles using the speed, right? Because the relationship that we would use here is that, okay, in 1 hour, the motorcyclist goes 71.3 miles. And if I know how many miles I'm going, I can then get to centimeters somehow. So we'll do miles to feet to inches to centimeters, we'll say. Let me fill in all these relationships here. So how many minutes are in an hour? Well, that's 60 minutes in an hour. There are 5,280 feet in a mile. And then in a foot, there are 12 inches. And then down here, 1 inch is equal to 2.540 centimeters. So knowing all of these conversions, I can then get to the answer. The real trick is setting up this blueprint to figure out how do you get to the answer. So let me set up all of our units and we'll do the problem. So 32.6 minutes. I'm going to turn minutes into hours, like we said here. We're going to turn hours into miles. Oh, these units cancel. I didn't actually do that. We'll turn miles into feet. We'll turn feet into inches. And then we'll turn inches into centimeters. Now, do you have to do it exactly this way? No, not necessarily. You could, once you get to miles, you could go miles, kilometers, meters, centimeters if you wanted to. There are multiple ways to get from miles to centimeters. Now I just got to fill in all these numbers. So 60 minutes in an hour. He's going 71.3 miles per hour. There are this many feet in a mile, this many inches in a foot, and this many centimeters in an inch. So I'm going to put all that in the calculator. And the number that I get is 6.23 times 10 to the 6. That's the answer I get for that one. So some 6.2 million centimeters of distance was traveled going from Everett to Seattle. So again, this is probably the hardest part, is getting this all started. Like, what do you do? And the answer is look at your units and try and establish a way that links them together so that you can get to what the question is asking. Because you know you're trying to solve for centimeters. How do the things that you are given relate together? And the answer is, well, time and speed can be used to convert a amount of time into a distance. And once you get to a distance, getting to the correct unit is easy. Well, it's not easy, it's trivial, I should say. You still have to do all the algebra. I'll put that back on the screen there. All right, the next one is... Oops, I ran out of space, so I'm going to have to clear this. You can pause the video or go back. So the dosage for a pediatric medication is this teeny tiny number. There you go. If you have a conversion table in your textbook, you can use that. If it's off by a little bit, it shouldn't affect your answer too much. Like, if it's only off in the last digit. If it's off by a lot, though, that could be an issue. If you aren't sure, type in what your conversion table says, and I'll let you know. But it shouldn't matter, I don't think. All right, so this is the medication to give to a child per kilogram of child weight, and then my child that I am treating here has this weight. Now, this is how much you want to give them if they weigh 1 kilogram. Well, my child doesn't weigh 1 kilogram, they weigh this many pounds, right? Well, if I know how many kilograms I have, then I can get my grams of medication out of that. So the first step is going to be to turn pounds into kilograms. So let's rate those relationships here. 1 kilogram is 2.204 pounds. And then 1 kilogram of child is 0.00132 grams of medicine. So that's what we'll do. So we'll start with their weight. We'll turn pounds into kilograms. And then we'll turn kilograms of child into grams of medicine. And you'll notice I'm being specific here just so that it's clear what we're doing. You aren't turning kilograms into grams and then giving them 1,000 grams of medicine, because that would be very bad. All right, so 1 kilogram is 2.204 pounds. And then per kilogram of child, you administer this much medicine. So that'll be the grams of medicine that we administer. So we should give her 0.0122 grams of medicine. Or 12.2 milligrams. So she gets the kiddo tablet. All right, that's the second one. And then the last one you gave me was current market cost of a metal ore is this much per kilogram. What's the volume in cubic centimeters? That costs $169. Here's the density. All right. So I ran out of space again. So I'm going to hit clear on that again. So I give you a bunch of information for this problem. So it's $5.88 per kilogram of metal. The density is 13.4 grams per cubic centimeter. And I want to spend $169 and buy as much as I can. So how many cubic centimeters can I buy with that? Well, if I know how much I want to spend, that immediately tells me how much mass I can buy. So I can buy some number of kilograms. And then using the density here, I could turn mass into volume. So I need to turn kilograms first into grams so I could then turn it into cubic centimeters. And that's what the problem wants us to do, is tell us what the volume that I can buy is, right? So again, it's just looking at the units and seeing how they all connect together. So how much money can I buy with what? Well, it's $5.88 will get you 1 kilogram. And then a kilogram is 1,000 grams. I'm going to write that as 10 to the 3. And then grams to volume is just, well, in 1 cubic centimeter, there are 13.4 grams for this metal. So let's set all of that up. So I want to buy $169 worth of metal. I'm going to pay some amount per kilogram so that my money cancels out. That will be a number of kilograms I can buy. We'll turn kilograms into grams. And then we'll turn grams into volume. And then since that's the only unit that's left over, that'll be the units of my answer. So now let's run the numbers. So this much money per kilogram, 1 kilogram, $5.88. There's 1,000 grams per kilogram right there. And then this is the density, so 13.4 grams per 1 cubic centimeter. And we'll put all the numbers in. 169 times 1,000 divided by $5.88 times 13.4. And I get 2,144.8 cubic centimeters, but I only get 3 sig figs, so this would end up being 2140. All right. No problem. Are there other questions that you have? Let me know. I'm just going to hang out for a bit here, see if there's any other questions. I'm sitting here talking and I didn't realize I was muted. Can I repeat the last number before 2140? I'm not sure what you meant. Oh, what did I type in? Yeah, so 169 times 1,000 divided by parentheses 5.88 times 13.4. So If you're typing that in the calculator, make sure you enter it like this. So 169 times 1,000 divided by parentheses 5.88 times 13.4. So do that. And that should get you the right answer. It would be 2144, I think it was, yeah. Which we then round to 2140 for 3 sig figs. If there are other questions, let me know. Cool, yeah, if you're good, then hooray. You're getting a different answer. Did I type something in wrong on my calculator? 169 times 1,000. Divided by 5.88. What number are you getting? Yeah, I got the same thing. While you're doing that, I'll answer Sadie's question here. So, check the elements that would react similarly with iodine based on your knowledge of the periodic table. Okay, so the element that you are reacting is calcium, and you add iodine to it. And so the question is asking, yeah, I know you have a character. I also have a character limit too, so I also get to talk. um, so for that reaction, you are reacting calcium with iodine, and then the question is asking, what else would you react with iodine and get the same result? And so your choices are a bunch of different elements, and you want to pick elements that react similarly to how calcium reacts. And so this is a question from chapter, I want to say it's 3. And remember that elements that are in the same group, so the same column on the periodic table, react similarly. So if you react sodium with iodine, it won't be the same as calcium because they're in different groups. If you react tungsten with iodine, they'll react differently because they're not in the same group. Phosphorus is in a different group, but barium is in the same group as calcium, so it should react similarly, and beryllium is also in the same group. So the answer should be barium and beryllium. And the reason for that is because they're all in the same group. That's a huge number, and I'm not quite sure I got it. Let me see here. 169. I actually don't know how you got that number, because it's so big. Oh, yeah, that'll do it. Yeah, it looks like I just tried multiplying all the numbers together, and I got that number, actually. So, yeah, put the division symbol in there, and then you should be good, because... Other questions. Yay. Cool, okay. Other questions, let me know. Can I repeat Sadie's question? Yeah, so... Actually, you know what? Let me write stuff down for that, too, so... I'm in the wrong window. Hold on. There we go. Clicking on too many things. So the question that Sadie asked was, if calcium reacts with iodine and you get some sort of reaction, and so this will just be my reaction symbol, what else can you react with iodine and get the same sort of outcome? So, and the way that you determine that is that any element that's in the same group on the periodic table will have similar reactivity. So if you remember the experiment where we dropped all of the metals in water, so I dropped sodium and then potassium and they all burned and exploded and it was pretty. This is that question, basically. So what elements are in the same group as calcium? And it turns out that of the choices that are offered, so what were choices? So there's phosphorus, tungsten, sodium, barium, and beryllium. So calcium is in group 2. Phosphorus, though, is in group 15, so that doesn't work. Tungsten's in like group 6 or something, so that doesn't work. Sodium's in group 1, that doesn't work. But barium and beryllium are both 2, so they're all in the same group, so they all have the same or similar reactivity. So that's what that question was asking. Excuse me. All right. Last call for questions. Yeah, we can talk about polarity. Oh, that reminds me, yeah. So I had a student who asked me to talk a little bit more about electronegativity and bond polarity, so let me do a little bit of a discussion on that real quick. So we know what electronegativity is. It's the giant chart that has the electronegativity numbers on it. So we had 4.0 for fluorine up here. And then down here it was like something like that. And so electronegativity decreases as you go down and to the left. And so what you want to do is whenever you have a molecule that has any sort of bond, so single, double, or triple bond, it doesn't matter. If you look at the electronegativities, so the electronegativity for carbon is 2.5. This is just off the chart. And then for oxygen, it's 3.5. So the difference would be just subtract the two. And then remember that our range is 0 to 0.4. Nonpolar. 0.5 to 2 is polar covalent. And then we'll just say greater than 2 is ionic. So since this bond has a polarity of, or an electronegativity of 1.0, it would be this. So this bond would be polar covalent. So really what you have to do in order to be able to answer the questions about polarity is you need that chart. Where is my chart here? There it is. Can I get that on the end of slideshow? No, I don't want that. There we go. So if I get this on the screen, nothing will happen. Great. Okay. Oh, there it is right there. So this is the electronegativity chart. Oops, you can see that my text is kind of funky down there. So those are the numbers that I'm pulling. And so you just want to look at any two atoms in a bond. And so that will tell you if that bond is polar or not. And then the next thing that you can do with that is if you have a molecule, like say this molecule here, so if I asked you, is this molecule polar or not, you could say, well, up here I did C and O by themselves, and we found that it was polar covalent. And you could draw your arrow like this. So I'll do that over here again. Then over here for C and H, we would find that if I look at a C and H bond here, so this is 2.1, this is 2.5, the difference is that So this falls into nonpolar. So these guys are nonpolar, so don't even bother writing an arrow. So this molecule would then be polar. So that's the sort of thing that you're going to want to do for molecules. Is you're going to try and figure out what are the polarity of the bonds, and then use those arrows and sort of sum them together and do that arrow math that we showed you yesterday. Do you have the chart in the book? Yeah. So your chart will look a little different. It'll be smaller. My chart might be more useful because it has more numbers. And this chart is in the slides. It's in Unit 5. Oops. There we go. All right, last call for questions, and then we'll call it a day. Do you know specifically what the question was? So zinc is a transition metal, so that means that if you're asked about the charges on it, you're going to have to solve for it based on a formula. Or in other words, like, you need more information. That's okay. If you find it and can send it to me, send me an email and I'll see if I can answer your question. All right, I think that that's going to do it for today. If anyone has any more questions, let me know. You can either drop them in the Discord or send me an email. Happy to answer any questions you have. The only stipulation is that on Friday during the exam itself, I can't actually answer any questions. So if you email me about something on Friday, I can't actually reply to it, and you'll have to wait till Saturday. When will the Chapter 4 quiz results show? Did the quiz close? It closes tonight, so tomorrow I will release the quiz results. So sometime tomorrow. If I haven't done it by the time you check, email me, and then as soon as I check my email, I'll be like, oh, I have to do that, and I will do that. I probably will be up at midnight tonight, so hopefully I'll remember to do that. All right, yeah, that's really all I got. So if you have any other questions, let me know. Send me an email, drop a question in the Discord. Best of luck studying. Don't worry, you're gonna do okay. It'll all be all right.